everyone, we're going to use the principle of mathematical induction to prove that 8 to the nth power minus 1 is divisible by 7 for all integers, positive integers n. And we're going to make a conjecture. We're going to call this S sub n. That's not the sum sign for mathematical induction, based off divisibility definitions of 7. So basically I can rewrite this as 8 to the nth power minus 1 equals 7r for some r, for some integer r. Alright, so now we have to show that it's valid for n equals 1. So plug that in, equals 7. And so 7 times 1, in this case r would be 1, equals 7, and it's divisible by 7. So this is valid for n equals 1. In the second two steps, we're just going to set up this. We're going to assume that it's true for k. So we're going to write it like this. Again, for an integer r, and then show that it is true for s sub k plus 1. And that's for some t, integer t. This means there exists some number. So it's a lot easier to write it that way. Alright, so now all we have to do is prove this, and I'm going to go ahead and write them out again. So s sub k equals k minus 1 equals 7r, and the r is an integer, and then our next one and this one's a t, and for some integer t. Alright, now how we're going to do it is we're going to start with this one, and we want to end up making it look like s sub k plus 1. So we take our 8 to the k power minus 1 equals 7r, and multiply both sides through by 8. So put an 8 here and an 8 here. When you distribute here, you're going to get, this is a 1, so this is 8. Since we have the same base, this is going to be k plus 1 minus 8 equals 56r. Again, our goal is to make this look like this one. So what I'm going to have to do is add 7 to both sides. And I'm going to get 8 to the k plus 1 minus 1, which is our goal, equals, and what I'm going to do here is factor out a 7. So if I factor out a 7, I'm going to get 8r plus 1. So from here, what I'm going to do is let this be t, because I want it to look like this line. So I'm going to let t equal 8r plus 1. That's why we have different symbols here, different variables there. So now I can rewrite this as 8 to the k plus 1 minus 1 equals 7t. And we finally matched it up. So it's saying that since it's valid for n equals 1, it's also valid for n equal 2 and 3. So it's divisible by 7 for all integral values of n. And that's it. Thank you. Have a nice day. Bye-bye.